Hey everybody, in this video we're going to talk about graphically solving a system of linear and quadratic equations. So if we are given two equations, y equals negative 2x squared and y equals negative 2x minus 4, and we're told to find its solution, one way to do that is graphically. Now I can graph this blue line, which is the parabola. If we remember, it's a parabola that opens down because of the negative, and it's stretched vertically by a factor of 2. If we don't remember this, we can go ahead and graph by building a table. If I plug in 0, negative 2 times 0 squared is 0. So I'll have a point at 0, 0. If I plug in 1, 1 squared is 1 times negative 2, I'll get negative 2. So at 1, I'll have negative 2. At negative 1, I'll also get negative 2, etc. And then we go ahead and we fill in our points here. Let's also plug in the point 2. When I plug in the point 2, I'll get negative 8, which is here. Now, y equals negative 2x minus 4 is the line with the y-intercept at 0, negative 4, and then a slope of negative 2. So I'm going to be at negative 4 and then go down to over 1. So that's just a quick review of where these graphs come from. Now, to determine the solutions for these, I need to find the points where they intersect, which happen to be here at these 2 points. Now, because of the way these functions intersect, they happen at these whole values 2, negative 8, and negative 1, negative 2. So our solutions to this are going to be 2, negative 8, and negative 1, negative 2. But we can always check and make sure these are right by plugging in negative 1 into both equations and seeing if we get negative 2 out for y. So if y is negative 2, will that be equal to negative 2 times negative 1 squared? Yes, it works for the first one. So for the second equation, we plug in negative 2 for y. Then we have negative 2 times negative 1 minus 4. Well, this becomes a positive 2, and 2 minus 4 is negative 2. So that point works for both equations, so I know it's a solution. I will do the same thing for the next point to determine if it was correct for this point. And that's how we're going to check for these. And that's all we do when we graphically solve systems of linear and quadratic equations.